Hey, what's up, guys? Here we are with 1.8, combinations of functions and composite functions. Just as two real numbers can be combined by operations of addition, subtraction, multiplication, and division, we can do that with functions as well. For example, functions given by f of x equals 2x minus 3 and g of x equals x squared minus 1 can be combined to form the sum, difference, product, and quotient of f and g. So addition and subtraction, guys, should be pretty easy here. We're just combining. There's no other x squared, so we're going to have x squared. There's no other regular x's, so plus 2x, and we got a minus 3 and a minus 1 for minus 4. Okay, subtraction, just remember to distribute the negative to both. So now this is a negative x squared plus 2x, a minus 3, and now this is going to be a plus 1, negative, negative, so minus 3 plus 1 is only going to be a minus 2. All right, multiplying. Okay, multiplying them out, this is going to have to do this little FOIL. Zoom out just a touch. I'm cutting off just the left side there, aren't I? All right. So 2x times x squared, you're going to have 2x to the third minus 2x minus 3x squared plus 3. Maybe you want to rearrange that. Excuse me, put them in order. 2x to the third minus 3x squared minus 2x plus 3. And with division, guys, I'm pretty sure for just this, because this is just the intro lesson here, this is chapter 1, I think they just want us to stack them up. F divided by G, so 2x minus 3 over x squared minus 1, okay, and say what the bottom can't be, all right, any domain issues. So I can't have x squared minus 1 equals 0. I can't have x squared equaling 1. So x cannot be plus or minus 1. X, that's terrible, sorry. X cannot equal plus or minus 1. All right, that's what they just want you to do, is to stack them up, F on top, G on bottom for the division, and then list any domain restrictions. You don't have to worry about factoring and canceling stuff out. If if there's something completely obvious to you immediately right away, maybe go ahead and do it. But I think for the most part, it's just going to be stack them up and say what the bottom can't be. The domain of arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. In the case of a quotient, f of x over g of x, you have to consider further restrictions such that g of x does not equal to 0. All right, and there's just our properties, okay, what it would look like. F plus g of x, just the same thing as f of x plus g of x, just what we did there. F minus g of x, subtract the 2, multiply the 2, divide the 2. All right, more examples. Given f of x equals 2x plus 1 and g of x equals x squared plus 2x minus 1, find f plus g of x and f minus g of x and evaluate. Okay, so let's do the plus. Well, we'll show all the work here. So we got 2x plus 1 plus x squared plus 2x minus 1. All right, so we got our x squared, 2x plus 2x, we got a plus 4x, plus 1 minus 1 is going to cancel out. So we just got x squared plus 4x. All right, what if it's, evaluate here when x is 3. So when x equals 3, we'll have 9 plus 12 for 21. And when x equals 2, sum is x equals 3, that 2 is for the difference, so I don't need to do that one. All right. And the difference one, 2x plus 1 minus x squared plus 2x minus 1. Distribute your negative sign. Negative x squared minus 2x, positive 1 there. Minus 2x plus 2x, those are going to cancel out. Plus 1 is going to be a plus 2. Tricky stuff here, guys. Okay, be careful. This is negative of x squared. So negative of 2 squared. A lot of people want to tack that negative onto the 2 first and then square it. Not how it's going to work. So this is going to be negative 4 plus 2 for a final answer there of negative 2. Alright, we got 2 more functions, and we're multiplying them, and then finding out what the product would be when x is 2. So we got 5x plus 2 times 3x minus 4, 15x squared minus 20x plus 6x minus 8 minus 14x minus 8. Okay, and then we're plugging in 2. So 15 times 4, 14 times 2, so we got 60 minus 28 minus 8 more, 32 minus 8 more, we should be having 24. Got a little sloppy over here. I'm trying to reach around. It's like reach around my computer and still write over on that side under the Elmo. Moving on. Example 4. This time we got a division one. F divided by G. Got a little, I don't know what's going on up here. F divided by G, and find the domain. Alright, so piece of cake. Just stack them up, guys. Just stack them up. That's all we're doing. We got x squared on top, 1 minus x on the bottom. Alright, and our domain restrictions here, we just can't have x cannot be 1. Composition of functions. Another way of combining two functions is to form the composition of one with the other. For instance, if f of x equals x squared and g of x equals x plus 1, the composition of f with g is f of g of x. Okay. It would be equal to f of, well, what is g of x? G of x is x plus 1. So we're doing f of x plus 1. We're taking what g of x is and we're putting that into the f equation. Okay, if I do f of x plus 1, that's going to be x plus 1 squared, x squared plus 2x plus 1. Okay, f of g of x. So what's g of x? X plus 1. Now do f of that whole thing. So x plus 1 goes into the f equation. Okay, x plus 1 squared. Shortcut for parentheses squared. First one squared, last one squared. Okay, multiply these two numbers together and double it. Put it in the middle. Okay, let's see here. Yep, composite functions, we got it. Bada bing, bada boom. Alright, here we go. F of x equals x plus 2. G of x is 4 minus x squared. And these are supposed to be open circles, f of, not closed circles for times. Okay, so this is really f of g of x. Okay, so g of x is 4 minus x squared. Alright, so then we have that is going in for the x. 4 minus x squared plus 2. 6 minus x squared. Okay, f of g of x. So you're taking the g equation, putting it in for x. That whole thing goes in for that one x in the f equation. And it gets really confusing when there's more than one x over here. Okay, g of f of x is going another way. G of f of x. So we go inside out. So we're taking the f of x, x plus 2, and putting it over here into the g equation. 4 minus x plus 2 squared. 4 minus, okay, this is tough here with the minus, be careful, okay, x squared plus 4x plus 4, and now take the negative sign to everything inside. We'll have negative x squared minus 4x, negative 4, positive 4 cancels out. Okay, g of f of negative 2. Alright, so here we have g of f of negative 2. So, when there's an actual number, okay, again it goes inside out. Do f of negative 2 first. Okay, negative 2 plus 2 is 0. So f of negative 2 would equal 0. So now I'm doing g of 0. 4 minus 0 squared is going to be 4. Put negative 2 into f. Negative 2 plus 2 is 0. Take that answer, 0, put that into the g equation. 4 minus 0 squared is going to give me 4. Okay, compare that with what we just did over here. Okay, this is g of f of x, so technically we should be able to just put this negative 2 over here. Negative 2 squared is positive 4. Negative of that is negative 4. Negative 4 times negative 2 is positive 8. Negative 4, positive 8 would be a positive 4. Okay, moving right along. Find the composition f of g of x when f of x is the square root of x and g of x equals x squared plus 4. So we want to know f of g of x. So I'm taking the g of x equation and putting it in here. So we got f of x squared plus 4, giant square root, and then it's just really easy because there's only one x, there's nothing else in there. So all this just goes in place of that x. Okay? Don't try to do that square root there unless it's something that's perfect square, completely obvious. Don't try to simplify it there. Okay, now we got to think about the domain. Okay, the domain for g of x is all real numbers. No issues here. Okay, but anything that we put into this is going to come out positive. In fact, the smallest it could be is 4. The smallest it could be is 4. All right. Would 4 and numbers bigger than 4 give me any issues over here? No. Okay, the domain for the square root of x is we need things to be 0 or bigger.
Can I look for you in the chat?
We need this to be 0 or bigger. So we won't have any issues because the smallest this could be is 4. So we're just going to still have all real numbers because all real numbers are going to give us 4 at the smallest over here, and then that's going to be fine over there. I'm good on those, I think. Thanks. Yep.
Looks like you got a handle. That's handle.
Now this is recording, so now you're fine.
Did I screw it all up?
No,
Swearing.
it's fine, yeah. They won't even notice. Last one, guys. Last one. In examples 5 and 6, we did composition of two given functions. In calculus, it's important to be able to identify two functions that make up a given composite function and then go backwards, like undo it, okay, or decompose it. Look for an inner function and an outer function. Okay, and it depends on how you look at this, guys. There's more than one. Technically, I think there's more than one way to look at these, or at least in some of them. You could see more than one different thing. So if we were looking at, where's our example one they gave us? So if we have x to the third and 3x minus 5, we'd have 3x minus 5 cubed. Okay, 3x minus 5 in parentheses cubed. So if you could unpeel that, you could maybe see that you're going to have something being cubed. So that would be your outer function. Something's going to be cubed. And then here's your inner function, 3x minus 5. Okay. So for 7, find two functions, f and g, such that f of g would equal this. All right. So like there's many ways. Okay, number 1, you could have just the cube root of 8 minus x is your first one. And then your second one, your outer one, could be x divided by 5. Okay? So that way, when you did f of g of x, this is going to be your g, and this would be your f. All right? Cube root of 8 minus x. And then you put it in, and now we're going to take that divided by 5. That's probably the easiest one to do. Let's see another option. Maybe your g is 8 minus x, and then your f is the cube root of that all over 5. Okay, something like that. There's more than one way to do it. But for many of them, okay, not necessarily for all of them. Sometimes it's going to be pretty obvious. Okay, 8. Last one, the number n of bacteria in a refrigerated food is given by n of capital T equals, there you go, where T is between 2 and 14. Capital T is the temperature of the food in degrees Celsius. When the food is removed from the refrigerator, or the power goes out for an extended period of time, something we can relate to there, the temperature of the food is given by that, where little t is time in hours. So step 1, we're trying to find the composite of n of capital T of little t and interpret its meaning. Okay, so n of t of little t. So we're going to do n of, what's our t of little t function? 4t plus 2. All right, so now we got to take 4t plus 2 and put it in for all those. So 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. This is a little bit harder to do mentally, to square that. Okay, still first one squared, 16t, back one squared plus 4. Multiply those two together, 8t and double it, plus, that's 16t squared, plus 16t. We can distribute this one already, minus 320t, minus 160, plus 500. Okay, now I'm going to distribute this 20, 320t squared, plus 320t, plus 80. I'll write these all out again. 500 minus 160 plus 340. All right, so positive 320t minus 320t, that's gone. We're going to have 320t squared. 340 and 80 should be plus 420. Okay, so this should be the number of bacteria in a refrigerated food T hours after being removed from the refrigerator, or, our adjustment to that problem, the power going out for a while. Okay. Find the time it would take for the bacteria count to reach 2,000. So we know what the bacteria count is. We're going to set it equal to our equation. Subtract that over. 1580. Okay, let's divide. Oh, sorry guys, a little low. 4.9375. Square root, and we're going to get approximately 2.2 hours. After 2.2 hours, it'd be about 2,000 bacteria. Yuck. Yuck, yuck, yuck. All right. So there you go, guys. There's the notes. Let's see if we can handle the suggested homework problems that are posted there on Schoology. All right. Thanks for watching. Good luck.